Welcome to the Planet of Maths channel. Today we will talk about special products, and it will be the formula for the cube of a sum and the cube of a difference. Before I move on to solving examples, I wanted to briefly explain where this formula comes from and how to remember it better. For this, Pascal's triangle will come in handy, which is a triangle that has only ones on both edges. And we fill in the middle here as follows. In this spot, we write the sum of the two numbers above it. If we add this one and this one, we get 2. Then we will write the number that is the sum of these two numbers. 1 plus 2 is 3. In this place, we'll write the sum of these two numbers. We'll end up with another 3. In this spot, we'll put the sum of 1 and 3, which is 4. Here, we'll put the sum of this 3 and that 3. Here we will write the sum of 3 and 1, which is 4. This triangle helps us with the special product formulas. It's already useful in the formula for the square of a binomial. In this formula, we have 1, 2, and 1. The number 1 is invisible here. The number 2 is visible here, and the other one is here, also invisible. We don't write them because they are simply unnecessary. In the formula for the cube of a sum, we will use this line. 1, 3, 3, 1. We have 1, we have 3, we have 3, and we have 1. Apart from these numbers, we have this. First, this a we raise to third power, which is the highest one here. At this point, a is to the power of 2, which means we move one step lower. Here, a is to the power of 1, which means a. And here is a to the power of 0. 3, 2, 1, 0. It will be the same with this b term, only here we go from the end. B cubed will be here at the very end. Here is b cubed, so here's b squared, here's b to the first power, and here is b to the power of 0. We almost have the final formula. We just need to remove unnecessary things. This one, we won't write this one anymore. And we won't write b to 0 either, because it's 1. The 1 in this situation is unnecessary. So from this part, we actually have a to the power of 3. This part doesn't change at all. And this part doesn't change at all either. And here at the end, the 1 is redundant. A to the power of 0 equals 1. So another redundant 1, leaving only b to the power of 3. And here we have the formula for the cube of a sum. The next formula for the cubes of the difference looks almost the same as here, only the signs change. Here we had a plus, it becomes a minus. And at the very end, there was a plus, and in the second formula, it becomes a minus. The rest is identical. Now let's start with some examples. We use the formula for the cube of a sum. Our a here is x, and our b is 2. If we need to raise a to the third power, according to the formula, we need to raise this x to the third power. Then in the formula, we have plus 3. There is invisible multiplication by a squared, that is x squared. And here is multiplication by b, which means by this 2, because this is our b, then we have plus 3. 3 times a, which is times x, and times b squared, which is times 2 squared. A plus b to the power of 3, meaning plus 2 to the power of 3. Now we need to raise to the power whatever we can. We'll leave this x cubed for now because there's nothing we can do with it. I'll copy this part for now. I will rewrite this 3x, and here I have 2 squared, which is 4, and plus 2 to the power of 3, which is 8. X to the third power doesn't change at all. Here we have changes. In this part I can multiply 3 by 2. From this I get 6x squared. In this part I can multiply 3 by 4, and from that I get 12x, because this x doesn't change. And at the end, there is plus 8. And that's the end of the example. In example B, we have the cube of a difference, which is x minus 4 to the power of 3. Now we use this formula. Our a is again x, and our b from this formula is 4. So we have a to the power of 3, which is x to the power of 3. Then there is minus 3 in the formula. Minus 3 times a squared, and a squared is x squared. And times b again, which is times 4. Then I have plus 3 times a that is x. So here times x. and times b squared, which is 4 squared. And finally, it's minus b to the power of 3. In our case, b equals 4, so it's minus 4 to the power of 3. Now we just exponentiate what we can. There is no exponentiations here. 3 times x still doesn't involve exponentiation. Exponentiation is only here. 4 squared is 16. And the exponentiation is here. That's 64. 4 cubed equals 64. Now only multiplying. X cubed remains unchanged. Here you multiply 3 times 4, which is 12x squared. Here you multiply 3 times 16, which is 48 x's and minus 64. End of example B. In example C, we go a step further because our a is the expression 3x. Here you need to be careful, and you need to write parentheses. We use this formula because here we have a minus. We start with a cubed, meaning this to the power of 3, and it must be written in parentheses. This is a cubed. Then we have minus 3 times a squared, which needs to be again those 3x written in parentheses, except this time squared. And there's also times b, which is times 5, plus 3 times a, which is 3 times 3x, and times b squared, which is times 5 squared. And finally, minus b cubed, which is minus 5 cubed. We exponentiate what we can, and this time we can exponentiate in this sector as well. That 3 outside the parentheses must act on that 3. 3 to the power of 3 equals 27. X cubed is x to the power of 3. Minus 3 times. Here we exponentiate, and again the square acts on the number 3. It equals 9 times x squared, which is x squared, and then times that 5. Here I rewrite 3 times 3x, and I raise 5 to the power of 2, which is 25. And minus 5 to the power of 3. 5 to the power of 3 is 125. So the powers are done, and we only have multiplications left. Here we won't do any multiplication, we just copy it over. Multiplication goes here. 3 times 9 is 27, and then times 5 gives us 135, x squared. Here, 3 is multiplied by 3, which is 9, and then by 25, which equals 225x, minus 125. Here we have the end of example C. Moving on to example D, in parentheses, 2 plus 5x to the power of 3. This is the cube of the sum. This is our a, and this is our b. So let's do a to the power of 3, which is 2 to the power of 3. Then there is plus 3 times a squared. Our a is number 2, so we square the 2. And times b again, our b is 5x. Plus 3 times a, which is times 2, and times b squared. So the whole in parentheses is 5x to the second power, and finally b to the power of 3, meaning the whole b in parentheses to the power of 3. We exponentiate 2 to the third power, which is 8, plus 3 times 2 to the power of 2, which is 4, times 5x. We rewrite 3 times 2. Here we raise 5 to the power of 2, which is 25. X to the power of 2 also needs to be raised, which is x squared. And final exponentiation. We raise 5 to the power of 3, which is 125. We raise x to the power of 3, which is x cubed. Exponentiation is done, so only the multiplications are left. 8 stays the same. The multiplications here are 3 and 4, which makes 12, and then times 5, which makes 60x. Here we multiply 3 times 2, which is 6, and then by 25, which equals 150x squared. And we just copy it over. End of example D. In the example E, we raise 4x plus 1/2 to the third power, so we follow this formula. But this a in the formula here, it is 4x's. So we first need to raise this 4x's to the third power. This is our a to the power of 3, then plus 3. 3 times a squared, and a is this, so 4x. Now you need to square it. And also multiply it by b, meaning by 1/2. Next, we have plus 3 times a, meaning times 4x's, and times b squared, meaning times 1/2 squared. And finally, there's b to the power of 3. For us, b is 1/2. 1/2 to the power of 3. We exponentiate. First, 4 to the third power is 64. X to the third power is x cubed. Plus 3 times, here from the exponentiation, we have 4 squared, that is 16, times x squared, which is x squared, nothing happens here, and times 1/2. Here we can multiply 3 by 4, which is 12x, and we also exponentiate 1/2 to the power of 2, which is 1/4. Add 1/2 raised to the power of 3, and that is 1/8. We can't do anything with this. It has to be rewritten. Here in this middle part, we can multiply this 1/2 by this 16. 16 is 16 over 1, so the 16 and the 2 cancel out. Here we get 1, and here divided by 2 when we simplify, we get 8. So there are no more fraction bars, only multiplication is left. 3 times 8 is 24. 24x squared. Similarly, here in this part, we simplify 12 and 4, we get 1 from this, and here we get 3. So from this whole piece, we get 3x's and plus 1/8. End of the example. In example F, we have roots appearing, but we are still working according to this formula. This is our a, and this is our b. We need to raise a to the power of 3, meaning this cube root to the power of 3. Cube root of 2 raised to the power of 3. Then add 3 multiplied by a squared, meaning this cube root of 2 raised to the power of 2. And also times b, meaning times 3, plus 3 times a, meaning times that root. And times b squared, which is 3 squared, and finally plus b cubed, which is 3 cubed. We raise a cube root to the third power, the root and power cancel each other out, resulting in the number 2. Plus 3 times, and here we need to exponentiate the root. If we square this root, we get the cube root of 4. Because this square acts on this 2. Times 3 without change. Plus 3 cube roots of 2 stay the same, and times 3 squared, which is 9. Add 3 to the power of 3, which is 27. With the 2 we can't do anything. In this piece here we can multiply the 3 and the 3. That is equal to 9. Cube roots of 4. In this part, we multiply 3 by 9, which equals 27. Cube roots of 2, because nothing happens to this, plus 27. All right, and now we have just one more operation. We can add these 2 and 27, which gives us 29. We can't add these roots here, so we just transcribe them. This is the end of example F. In example G, we have roots again. We use the formula for the cube of a difference, because we have subtraction here. This is our a, and this is our b. First, it should be a to the power of 3. That is 1 to the power of 3. Then we have minus 3 times a squared is 1 squared, and times b, which is the cube root of 4. Plus 3. First, we multiply 3 by a, which is by 1. Then we multiply it again by b squared, which is the root raised to the second power. Minus b to the power of 3, which is this root raised to the power of 3. And we calculate. We start with exponentiation. 1 to the third is 1. 1 squared is 1. We write everything else down. Here, 3 times 1 equals 3. The cube root of 4 raised to the second power. This gives us the cube root, and the square acts on the 4, which gives us the square root of 16, because 4 squared is 16. Minus the cube root to the third power, it cancels out, and what remains is just the number 4. We simplify. 1 minus 4 equals negative 3. Subtract. And from here we get 3 cube roots of 4, plus 3 cube roots of 16, and that's the end. There's nothing more we can do with it. And that's all for this video. Thank you for watching, and I invite you to tune in for the next episodes on the Planet of Maths channel.